Jean-Louis Leroy is about to give us a sort of a continuation of Luis's talk. His talk is directly connected, and I'll turn it over to him right now. We need the mic for the talk. Yeah.
You're on. Hello, I'm on? Okay. Okay, well, first I hope that Luis convinced you to stop it with DDD, dogma-driven development. Okay, so I'm going to go into open methods in quite a bit of detail. Normally, no stone will be left unturned. I'll show you how to use them when they are useful, and since this is a DConference, I'll also give you a peek under the hood. So I'm going to use a little case study, which is very common. It's simply an IST, which represents an arithmetic expression. Don't pick on me for not using immutable and constant, so on. This is slide style D, okay? So here we have an interface node, which contains a function, a method, called value, which returns the value of the node as a double. And, well, okay, you know the drill. A number returns a value that it has stored, plus takes two nodes and evaluates the left and the right nodes and returns the sum of the values. Times returns the product, and it could go on and on. This is a very common example. And indeed, we can build a tree and ask the tree, give me your value. How much 2 times 3 plus 4 make? 14. Good. Now, let's suppose that we would like to render the AST in a certain format. Here I picked reverse Polish notation because force was my first language. So in force, you would render it as 2, 3, 4 plus times, and the result is 4, right? That's my personal taste. Maybe you prefer the Lisp way or the infix way. And how do we go about doing this? Well, if we follow Scott Meyer's algorithm, we're cornered. It needs, seemingly, 2 RPN needs to be virtual. So we have to make it a member function. It's not a good reason for doing so, but seemingly we have no choice. And then we get an instance of the banana, which comes with the gorilla, which comes with the jungle, because if you put this in a library and use it in application 1, maybe application 1 will want to render ASTs in reverse Polish notation, but maybe another application will not be interested in doing that, but it will still get the code for RPN rendering, right? So that's the problem you have with that approach to building libraries or reusable code. You end up with classes that often do too much and rarely what you need. So people have tried to imagine alternatives to this. I'm going to go over them. One is the ugly type switch. So we go over all the possibilities. We try to cast the node into a number. If it's if it works, we extract the value. If we can cast it to plus, okay, the code is there. And this is really not very good because it's not efficient. What if there are many options for the node? And more importantly, each time that we add a node subtype, we will have to update this function if we remember it. And so this is not great at all. And on top of it, if that function is in a library, maybe you don't have the option of modifying it. So when we encounter language limitations, often people will try to sell us patterns, like visitor. So here we go. That's a classic visitor. Inside node, you put an interface visitor with a function visit for number, plus, times. And in Node, you put a function called accept, which takes a visitor. By the way, I always forget which one is which. When I made those slides, I swapped them, and I had to change them. In the Node subclasses, you add overload for accept. Okay. Here we go. And then you create a subclass of, you derive a class from the interface, and you override each of the visit functions and do what's appropriate. There are many types of visitors. This visitor is really the simplest. Sometimes they traverse the tree for you, depth first or breadth first. It's an endless zoo. Personally, I find that absolutely atrocious because it's a lot of work. Again, we don't have the possibility to add a new node subclasses. The visitor is closed. So yeah, now we have a way of adding polymorphic behavior to the node hierarchy, but we have lost the possibility to add subclasses. And yet another way of solving that problem is to build a function table or a function hash table. So here we declare that we have an RPN formatter, which is an alias to a function that takes node, returns a string, and here we go. Using a static constructor, we can initialize that table with functions that cover all the possibilities. Okay? And then this is the interface to that table. Well, this is actually my favorite option so far, because this one makes it possible to add subtypes a posteriori. It's just very verbose. It's not very efficient because each time that you want to select the right function, you have to go through a hash algorithm and so on. It's quite verbose because you need to, inside each of the anonymous functions, you have to cast the node into the appropriate type. So it's quite heavy. In fact, here we're grappling with something which is known as the expression problem. So the expression problem is if you have a collection of types organized in a hierarchy and a collection of behaviors like evaluate, render to RPN, draw, like in Louis' example of, what was it called, Logisim. So you would want to be able to easily add new types to existing behaviors, and that object-oriented programming makes it easy. If you have a set of behaviors which is captured in a class or in an interface like Node, it's easy to add types to that collection of behaviors. You just subclass, right? Where languages like D and C++ are not so good is when we want to add behavior, new behavior, to existing type hierarchies. And the rendering function is that we are trying to teach our classes a new trick. So, and that expression problem often manifests itself in what's called multilayer architectures, where you have several layers. For example, typically you have a domain layer. Underneath you have a persistence layer, which allows you to save objects to relational databases, JSON files or whatnot. And on top of it, you have a presentation problem. So what Louis was describing was actually a multi-layer architecture. And personally, I encountered it when I worked on the project for the automation of the Belgian appeal court. And we had a domain layer with person, natural person, legal person, criminal case, and so on. And we needed to persist to a relational database, and sometimes we would have, list boxes with mixed content, legal and natural persons, which were parties to a case, and from the selection of the user, we had to return a new piece of user interface. So we did really need to be polymorphic on type. We needed to polymorphically create a widget of a certain type given an object whose type was not exactly known. So the solution I offered to you is called open methods. So an open method is simply a virtual function that is declared outside of a class. Okay? It comes with a bit of new syntax. You already saw part of that syntax here. So this is probably the most important piece. This says that we are declaring a function that is called toRPN and which takes a node. Virtual bang is just a trick to invent syntax. I would have preferred to use an attribute, but you cannot have attributes on arguments. So this declares a function which takes a node. And then we add specializations to that function toRPN. So here we say that we provide a specialization for a method which is called toRPN and takes a number. Okay, so careful, you need to put the attribute. It's the equivalent of override for virtual functions. And you need to put the underscore. It's just a convention, and you can override it. So now I declare specializations for toRPN of number, toRPN of plus, and the same for times, right? I have simply moved the virtual function out of the class. I need to add a little of mumbo jumbo. Of course, I have to to import the module. I also need, sadly, to call a mix in here. Well, more about this later. Okay? One more thing in main. First thing I do is to call a function called update methods. I'll tell you later what it does. It has to be called before calling any open method or after you dynamically load a shared object that would add classes or specializations to your program. Okay, now we have our solution from toRPN, but what about value? Because when I introduced that node hierarchy, I said, well, it looks natural to put value inside interface and subclasses, and nobody has reacted. I guess that Louis would have hated me if I didn't warn him, but it's probably not a good idea either. I mean, is it really the node's business to calculate its values? That sort of screams that it's an AST, which is going to be used in an interpreter. But what if I want to use it in both an interpreter and a compiler? In that case, the value functions will be of no use to the compiler. So I surmise that we should be anemic, like Louis likes to say, and move the value function out of the node hierarchy. So open methods comes with documentation. Here's a quick checklist. You have to import the module, of course. You have to call that mixin in each module which declares methods and defines specializations. virtual bank node. Virtual bank is just a way of marking the argument which is virtual, and a syntax for declaring specializations. And don't forget to call update methods in main, otherwise it crashes or it asserts. Okay? Any questions so far? So, yes?
In object-oriented programming, you can have a default method, which is basically your base method.
Yes.
Can you also declare a base method in open methods?
Yeah, you simply, here, in this case, you would simply define a specialization that takes a node. And there'll be more examples of this when I talk about, well, in fact, just now. Other question? No? Okay, so now this is a part I almost feel like skipping. I'm actually surprised that nobody asked me, can you use virtual on more than one argument? You're going to. The answer is yes. And it's called multiple dispatch or multi-methods. Open methods is also a library of multi-methods, but please don't walk out of this talk thinking, oh, I heard about multi-method. It's cool, but I never need them. And it is true. You can go to Wikipedia, look for multiple dispatch. Rarely, they're very convenient, but very rarely, even in systems, in languages in which they are natively supported. They represent maybe 5 or 6% of the cases. However, since I have time, okay, let's go over it. It's occasionally useful to be able to select a behavior depending on the dynamic type of more than one argument. So a very common example involves either hierarchies of shapes or hierarchies of matrices, if you want to add two matrices. And matrix is actually a root type. A matrix can be a diagonal matrix, a dense matrix, a sparse matrix, and so on and so on. You really want to tune the addition algorithm to the actual type of the two operands. If you're adding dense matrices, you have got to add all the elements. But if you're adding two diagonal matrices, well, first, you're probably not going to store all the zeros, and secondly, you don't need to add them. So it's important here, if the two arguments are diagonal matrices, that you recognize it and return a new diagonal matrix, storing only the new diagonal and sum only the diagonals. So that's the classical example. But I've been told that multi-methods are often used in games. One of the major languages for writing text-based games, called TADS, supports multi-methods natively. So here's a little example that all the people will recognize. Here we have a multi-method with three virtual arguments, character, creature, and device. And we have a series of overloads. Fight human, creature, axe. In that case, we say, oh no, a mere human cannot wield an axe. But if it's a warrior, yeah, it will be able to slay any creature. Or except if it's a dragon. With a warrior with an axe attacking a dragon is just going to die. Well, that's okay. And for those who remember the old game Adventure, it turns out that if a human tries to kill a dragon with his bare hands, it works. It took me like an entire week before finding how to pass the dragon. Back to your question, no. I was wrong, this is not the example you were seeking yet, but it will come. So the syntax, well, it's the same. You simply decorate more than one argument with virtual bank. And by the way, all the arguments need not be virtual, right? You can have any combination of virtual and non-virtual arguments in any order. So at this point, I should explain how the system selects the right specialization in presence of multiple virtual arguments. And I could start talking about partial ordering and blah, 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 but there's no need. You already know the rules. It's exactly the same rules as when you use overloading. Exactly the same rules. Which means that sometimes you can create ambiguous situations. If you have, for matrix, a specialization to add a diagonal matrix and a dense matrix, and another specialization to add a dense matrix and a diagonal matrix, the dispatcher will not know which one to prefer. It's a design choice. In certain systems, it will pick one. And in that case, it will assert. Well, it will call a function that you can replace, and by default, it will assert. And how do you solve that problem? Well, you provide a specialization that shadows the two ambiguous specializations. Okay? So back to this question. Is this object-oriented programming? And what is object-oriented programming? Let's have a little bit of history. OOP was invented in Sweden, I think, as part of the Simula language. We're back to simulations. So Simula 60 was the first language to introduce virtual functions. They realized that they had discovered something more general, so they moved all the simulation code, a part of the language, to a library, and kept just the virtual functions. And very stupidly, they called it Simula 68. So everybody said, oh, cool, but I'm not working in simulation, so it went unnoticed. Until, in 72, Alan Kay and company invented Smalltalk. Who has programmed in Smalltalk here? Okay, that's quite a bit of people. So Smalltalk departed from Simula in that it resembled more Lisp than Pascal, which was the root of Simula. And one of the great successes of Smalltalk is that it came with a very powerful metaphor, which is that the world is organized as independent objects that communicate by sending messages to one another, right? For example, an animal can be a dog or a cat, and you send it the stimulus, kick. You kick the animal, and the animal reacts according to its nature. If it's a dog, it barks. If it's a cat, it meows. And if it's a pit bull, it barks and bites back. So you don't have to, it's not the rest of the world which decides what the animal does, the animal decides by itself. Okay, it is, however, questionable that it is in the nature of an animal to be kicked, by the way. So, but in Smalltalk, you can add methods to existing classes, and it can lead to a big mess. So Smalltalk probably is the language that made OOP known to the masses and popularized the idea of OOP. And then immediately afterwards, all the existing languages were getting OOP extensions. C got C++. Personally, I wrote an object-oriented extension to Forth, because Forth is an extensible language. And then people wanted something simpler, so they had Java and so on. One more word about that message sending business. In Smalltalk, when you evaluate 1 plus 3/4, what happens is that 1 and 3/4 are two objects, an integer and a fraction. So integer 1 receives the message plus with the argument 3/4. And then they engage in a little discussion in which they decide that, after all, fraction is more general. So integer agrees to convert itself to a fraction, and then we are done. Yes? Oh, no, it's not a question. So note that if you evaluate 3/4 plus 1, something similar but different happens. So the process is not really commutative. So Smalltalk actually deserves its name, that all that chattering for deciding how to add each other can get quite messy. But when Smalltalk began getting talked about around 80 something, in the Lisp community, Lisp is also an extensible language, which I'll talk a little bit about in a lightning talk. They also experimented with several ways of doing object-oriented programming. And eventually, they created a common Lisp object system. And here, it's not objects talking to each other. It's more like selecting the most appropriate, the most specialized, the most specific algorithm given a series of parameters. So, is this object-oriented programming? Well, it does use inheritance and polymorphism. But it doesn't insist that objects are the unit of organization. It's still the algorithms, it's still the functions that occupy the front stage. And what of encapsulation? Well, it actually increases encapsulation, because have you ever noticed that most of your virtual functions could be written in terms of the public interface anyway? They actually have no need to know about the private parts of the objects. Again, they're inside a class because the language gives you no choice. Okay, so this is, let's say, the philosophical part of the talk. Are there any questions at this point before I talk about the implementation? No? Okay. So I'm going to show you how this is implemented, and this is actually quite interesting because you can implement this sort of thing and make it look almost as if it's native to the language, and yet keep it very efficient. Let's take another example, a payroll application. So I have two hierarchies, role with subclass employee, and manager is a subclass of, employee is a subclass of role, which is abstract, or an interface, and manager is a subclass of employee, okay? Founder is a subclass of role. Founder is not an employee. And then we have expense, which I will abbreviate as X when I need to abbreviate, which has two concrete subclasses, cab and jet, private jet, and an abstract subclass, public, which has in turn two concrete subclasses, bus and train. Okay? That's our little two hierarchies. Now I'm going to define two functions. One which determines how much an employee should be paid, and another one that decides if an expense is approved for a certain type of employee or role. So first, the pay method. Pay is an open method that takes one virtual argument, which is of type employee, and it has two specializations. Pay an employee, and it returns a salary. And then we have a specialization which is quite interesting because, manager is an employee. So here we have a specialization for pay in which we call the super method. This is the equivalent of super. It calls the method that would have been called if the current specialization had not existed. Okay? And then we have the approve multi-method, which takes two virtual arguments, role and expense, and we set the rule. And now back to your question, here is a case where we specify the general case. We simply provide a specialization for role and expense, which is going to be used if no more specialized function exists. So by default, we say, no, don't approve this expense, unless we are overridden, unless we are in a more specific case. What do we have? So by default, it's not approved. An employee can take public transportation, that is a train or bus. A manager can afford a cab. And for a founder, it's always true. Okay? So I'm going to go through the little bit of syntax I showed you before. What does mixin register method does? Methods, plural. It simply static imports open methods, and it introduces two new mixins. It's a mixin that mixes in. No, it's a mixin that mixins in. Okay, difficult to say. Register methods uses loops over all the members of the module and finds the declarations, the function declarations that contain parameters marked with virtual bang. And it creates, and for each of those, it creates a new function which takes the same parameter list, but without the virtual bang. And that is actually the entry point in your open method. So an open method, syntactically, is a D function. So you can pass it around, it's a normal function. So we have pay, which takes an employee and returns a string, and contains some code, which we are going to examine. And then we have that second pay method, which looks quite mysterious, and it doesn't even have a definition. It has the same signature, but with an additional method tag argument. So when register methods finds a method declaration, it instantiates a template that has several parameters. You can recognize the name of the function, the argument list, the return type, and the allocator. You'll see later what it means. So that function is going to be used to match specializations to method declarations. We have the same thing for for approve. Here, register method synthesizes a function that takes a role and an expense. And then again, that weird overload. And then register methods uses static constructors to keep track of all the methods which are in the module. More precisely, it generates the static constructors that will fill variables that will be later used when we need to calculate the dispatch tables. Actually, this is what it does. Currently, it doesn't create a function, it creates an alias to a function that lives inside the method template class, but this will change soon. Then we have register specs. That one is interested in finding all the functions that have the attribute @method. And once it finds one, it checks that it has the underscore in front. And then it tries to find which open method is being specialized, because the system supports overloads. Here we have 3 open methods. One is a multi-method, the other 2 are uni-methods. It's for multiplying matrices by matrices, matrices by scalars, and scalars by matrices. So how how does register specs know that this times is specializing the first? Well, it's quite neat. It simply tries to call that function which has no definition and which returns the appropriate method type. But it's called in a type-of, so it's not really called. That's a nice little trick. Okay, those steps happen at compile time. At runtime, when you call, well, before you call open methods, all those static constructors which have been generated are going to fill data structures. And then in main, you call update methods, and it examines all those data structures. It finds all the classes that are concerned by method calls. So including classes in modules which do not mention open methods at all. You can create methods that take virtual object. That part was quite tricky to write because class info contains the list of base class and interfaces, but it doesn't find it doesn't know the derivations. So, but it was possible. And then it's going to calculate all of data structures and put them in a single big vector. So when dispatching a method, for example, the pay method, the pay uni method, this implementation uses a mechanism which is very similar to virtual functions. It uses a dispatch table. There is no hash table. It uses what I call a method table, which is very similar to the virtual function table. But when we have an object, how do we locate the appropriate method table? Well, we have that deallocator field in class info, which is very rarely used. It's deprecated, isn't it? So the library checks that it's not used, and if it's not used, it uses that field to put the pointer to the method table. Dispatching a method with a single virtual argument, it looks very much like calling a virtual function. So who does not know how virtual functions are implemented? If you don't know, it's okay. Just one. Okay. So virtual functions are implemented with a table of pointers to functions, which is indexed by an offset which is fixed for a given virtual function. The only difference with open methods, because they are open, is that the pay method doesn't know, it doesn't have a fixed slot inside the method table. It's floating somewhere, because you can build the method tables only in update methods. The earliest would be at link time, if they were supported by the language. And this is how the code is performed. If I call pay, inside the method there is a static variable which is called slot strides, which contains the position, the current position of the function pay inside the method tables. For employee, we have the method table here, whose address is stored in the allocator. It turns out that here the first slot of that method table is used by approve. So pay uses the second slot. first try it's 1. And then we have the same for manager. And this is how the pay method is dispatched. We simply find the offset from the associated array of offsets, it's 1, and then we simply fetch a function pointer and call the function. Okay. So the performance is excellent, and I want to insist on this. It's almost as fast as virtual functions. That's why I took the trouble to show you the code here. A call to a uni method is 35% slower than a virtual function call. If it's called from class to class interface, it's a bit slower. And it's interesting to look at the code which is generated, and it's quite good. When you dispatch an open method, you have first to fetch the VPTR inside the object. The first slot of the virtual function table is the pointer to the class info. And in the class info, I have stored the pointer to the method table. That's what the first block of instruction does. It fetches the pointer to the method table. It also needs to fetch the position which is allocated to this method inside the function table. So here again, this time inside the method class, there is a static variable. It loads its address, and it reads the first value in that vector. And that it has all it needs. It has the pointer to the method table, the offset, it fetches the function, calls it. Okay, this is quite tight code. It's very good code, but it looks like it should be much slower than a virtual function, because a virtual function is very fast. It's 2 memory reads. You read the VPTR from the object, and you read the function which is at a fixed offset, and you call it. So it's two memory reads, and here I have, I think, 6. However, if you look at those 2 blocks, you see that they don't have any mutual dependencies. So my guess is that they actually execute in parallel. And here it makes sense, because I have 3 memory reads versus, well, 2 times 3, but they execute probably in parallel, versus 2 for virtual functions. That's probably where the 35% comes from. Okay, questions? No? For multi-methods, it's a little more complicated, but I want to save some time for other stuff, so I'll go quickly over it. So it uses a multi-dimensional dispatch table. The problem is that the more you add specializations and subclasses and also number of virtual arguments, that table can grow quickly in size. But they're sort of compressed, except that they're never compressed. They're actually built void of dependencies, and it's easier to just look at it. This is the dispatch table for our example. So Rx is the specializations that takes a role and an expense, EP, employee, public, and so on. And you see that bus and train share the same column, which is logical, right? Because we never specialized in terms of bus or train. We specialized in terms of public. Okay? I don't know. Anyone wants me to go over how a multi-method is dispatched? No? Yeah. Okay. Here's a summary of the performance. So here I make a race between calling a virtual function and the equivalent method with one virtual argument. As I already said, if it's a a uni method versus a virtual function is 37% slower, if the body of your function does anything at all, you won't even see it. It's not as good when the call is made via an interface. Even for virtual functions, calling via an interface is a bit slower, but for uni methods, it takes twice as much time. And for double dispatch, if you implement it via 2 virtual function calls, good luck to make it work with 3 virtual arguments, by the way. In that case, open multi-methods are 28% slower than the compiler supported 2 virtual function calls. Do I have time for this? Yeah, sort of. Maybe I can come back to this later. What if the allocator goes away? I really think it's deprecated. It's not a problem. There is already an alternative implemented in the library. You can say that a method uses another technique, and it's almost as fast. So, any questions? Yes?
For your performance measurements, did you also test this with PGO or not? With profile-guided optimizations?
No.
Okay. The reason I ask is because indirect calls, you can, if you know a set of likely candidates for your indirect calls, PGO will be able to optimize those, kind of devirtualize those calls. And I'm wondering how that will work with your. What LDC does at the moment is very basic, and I wonder how that interacts with the more complex indirect calls that you're doing. So it's interesting to study maybe in the future.
Yeah. I'll try to see if it helps. You can see that at least for a uni method with only 1 virtual argument, the code is very similar to a virtual function call, right? So there are chances that it can actually optimize it. I'll try. Any other questions? Yes?
Thank you. One of the reasons that you may be faster than you anticipated is that virtual function calls in D are slightly slower than you described. The vtable is actually inside the class info.
Mm-hmm. Okay, thanks. Okay, so I'd like to talk a bit about what could happen next, because working on this project gave me some. I mean, it was really a pleasure to write that sort of things in D. This is actually a port of a C++ library, which contains a lot of meta-programming, nightmare. However, there are a couple of things that were still missing for me to have a perfect implementation. So I'm going to talk about this. So, but in the future, I would like to improve the speed of method calls, especially when they are called from an interface. There's still a bit of a mystery here. I didn't expect it to be so slow. Well, slow. I would like to find well, currently you can already use templatized open methods. It works, but it requires a bit of help from your part. For example, nowhere in the runtime type information you cannot find the classes that are instances of class templates. So you have to register them manually using a mixin. But I have a really nice syntax in mind for nearly automating templatized open methods, and there are 2 things stopping me. Well, there were 2. Static for each in certain circumstances crashes, and Tim fixed it last night, so it's in a PR. So thank you. Also, you cannot really introspect function templates. You can find them, and you can say, oh yeah, there are templates, and you can find the template arguments, but we cannot find the function arguments. There's a PR which has been in review hell for I don't know how much time, but a long time, which enriches the threads, and that would allow me to do this. Or maybe Andre's new system. Okay, I would like to get rid of mixin register methods. It's perfectly fine if you use open methods. It's perfectly fine to say import open methods, but I really don't like that you have to say mixin register methods just afterwards. I would like to automate that. I would like it that just saying import open methods injects the mixin register methods inside the importing module. And that's actually nothing new. In Perl, for example, who has programmed in Perl? Come on, it's not a shame. Okay. So in Perl, when you use a module, when you import a module, it automatically calls module import. It makes a call to a function in a module each time that the module is imported. So it's loaded once, but if it's imported by 5 other modules, that import function will be called 5 times, receiving as an argument the module which is doing the importation, and it can do things like create functions. Luis and I have been discussing the possibility of writing a dip that would simulate, well, that would reproduce that behavior. Namely, you could somehow, with some syntax, declare a mixin inside a module like open methods, and that mixin would be mixed in each time that the module is imported. And this is where I would put my mixin register methods, which would be executed in the context of the calling of the importing module. And during a discussion with Luis and Ali, Ali said that that may be sufficient to move the support for building runtime type information out of the compiler. So imagine that object is implicitly imported. It could use maybe compile time introspection to generate the module info. Yes?
Generally with these things, moving out information that's already inside the compiler and putting it into the library, which then the compiler has to fetch again, has a big negative performance impact. So I would think twice about that.
Okay. Okay, well, that was maybe far-fetched, but imagine all those modules that create attributes, like, unit test frameworks and so on. I think that they could benefit from this feature. I would like to get rid of update methods. Well, no, frankly, I don't care. Calling that once in main, it doesn't bother me. What bothers me is that people keep asking me, you could get rid of open methods by using a static constructor. The answer is no. If you want to know why, you can talk to me later. But maybe we could finally decide of a way of ordering static constructors. Or Luis had an idea for changing the way, for getting rid of those static constructors. So he can send me a PR. And he would also like to have the ability to use open methods in modules which have cyclic dependencies. I'm not quite convinced by his arguments, but why not? And he has, again, ideas of how to implement it, so he can send a PR again. And then he would like to be able to dispatch not on the type of an object, but on the type of a field inside an object. And when he came up with that, I thought, well, that is so specific to your application. I don't think it should be supported by a library. And then I thought about the C++ implementation, and actually that's not different from what you want to do to handle smart pointers. because a smart pointer to T is not a T, but you want to dispatch on T. It contains a T. I have ideas on how to make this work. In fact, in the C++ version, it works. But as far as I can tell, in D, you cannot specialize a template outside of the module which has declared the template. Correct? Or I don't see how. It could probably be possible to extend my library to support Golang style duck typing. So polymorphism without inheritance, simply based on a set of functions which is available in a class. But I'm not all that excited by Golang, so maybe someday. And then finally, a message to Andrei. You want to remove magic from the language? Well, now you can remove virtual functions. They're not needed anymore. Okay, more questions? You have... Oh, I'm over time.
We still got time for a couple questions if anybody has one. Stephen?
Have you considered using the RT-info template inside the object?
Yes, actually, I spotted it very early, and also Ali told me about the monitor. I was looking for something I could hijack for my method pointer, right? And later, Andrei pointed it to me, and I don't like the idea because it requires you to build a new D runtime, right?
Well, one of the things that we've been trying to do is figure out a way to make it customizable in user modules. In some modules you can say, I'm going to extend how RT-info works.
Okay. My problem is the number of indirections, right? Because that is what's costing me speed. So I read those messages. Can we make a general facility for any library to blah, blah, blah? I would not use it. But I have something which may interest you here. It's my plan B. So if I cannot hijack the allocator anymore, what am I going to do? Well, I already have the solution. I simply use a hash of the VPTR. But not any hash. It's a perfect hash. A hash which is collision-free. Who knows that exists? Oh, good. Well, that's almost half. So the idea is that if you know the set of integers you're going to hash, and when update method runs, it does a finite set of VPTRs, you can find a very simple function which has the form x times m, where m is a fairly big integer, shifted by a certain number of bits. And you can find m and n so that it's collision-free. Okay? And how do I find m and n? It's easy. I simply do a random search. I try them until I find them. So, well, I try a certain value of n, which is the next power of 2 after the number of virtual pointers I have to hash. And I try 1,000 times to find m. And if I don't, I simply double the size. And it works very nicely. And that could be put in a library to do what you want to do with RT-info, maybe.
Okay, I think that's all we have time for. Thank you very much, Jean-Louis. Okay, everybody, we can go ahead and take a 10-minute break, and we'll see you back here for the next session. 9 minutes.